We've reached this point with AI where it can, like, whip up a Shakespearean sonnet or debug complex code,
Yeah,
which is just mind-blowing.
totally.
But when it comes to just talking to us, it's often stuck. Still feels like, text boxes.
Yeah, just text.
Imagine instead having a proper video chat with an AI that feels, well, real, like you're talking to another person. That's sort of the frontier we're looking at today.
Exactly. And we've got this really fascinating piece of research on our hands. It introduces a technology called OmniTalker.
OmniTalker.
Okay, think of it as the key to unlocking that truly lifelike communication for our AI buddies, giving them a face and a voice that actually feel, well, natural.
And that's precisely our mission for you today. We want to unpack what OmniTalker is all about, why it's a genuine leap forward, and how, even if you think, I don't know, a bite is something you take out of an apple, you can still grasp how this tech could really change things, your work, everyday interaction, that kind of stuff.
Yeah, it's got potential.
Our roadmap for this adventure, a research paper. Bit of a mouthful, this title. OmniTalker, real-time text-driven talking head generation with in-context audiovisual style replication.
Hey, yeah, quite the title.
But don't let the jargon scare you. The core ideas are actually surprisingly cool. Okay, let's dive in.
So the researchers start by pointing out something kind of fundamental, how clunky the current way of making talking head videos from text actually is.
Right.
They call it a cascaded pipeline.
Oh, a cascaded pipeline. Sounds complicated already. Like a recipe where you have to cook two completely separate dishes and just hope they somehow go well together.
That's a great analogy, actually. Yeah. First, you've got a text-to-speech system. That's the digital mouth turning words into sounds.
Got it. Step one.
Then you take that audio output and you feed it into a different system, sort of a digital puppet master, maybe, that tries to wiggle a digital face in sync with the voice.
Right, step two. And I can already see how that might go wrong.
Precisely. And just like if one of those dishes in our recipe is, well, a disaster, it can ruin the whole meal.
Right.
If the initial text-to-speech sounds robotic or, unnatural, that awkwardness gets baked right into the facial animation. The paper highlights a few key headaches with this two-step approach.
Okay, hit us with them.
Yeah.
But keep it simple. Think of me as your favorite, slightly clueless, but very eager friend.
Will do. Okay, first off, it's just complicated. You're juggling two separate AI systems, right? Which basically doubles the chances of something going haywire.
Makes sense.
Secondly, there's a delay, latency. It takes time to process the text into speech and then animate the face. Kind of like ordering food from two different restaurants. It's just going to take longer.
Right, okay, that lag.
Yeah. And thirdly, and this is the one we all notice, the synchronization can be really wonky.
Oh, yeah.
Think of those old kung fu movies where the lips are moving like a full second before or after the words. It's that kind of mismatch.
Ugh, those are the worst.
Yeah.
Just pulls you right out of it.
Exactly. And finally, the paper talks about stylistic discrepancies.
Stylistic discrepancies, meaning...
Meaning the voice might sound, I don't know, happy and upbeat, but the digital face could look completely flat or even sad. It's like the voice actor and the visual actor haven't even met, let alone rehearsed together.
So the digital person's face and voice are having completely different emotional experiences.
Got it. Okay. So how does OmniTalker step in to fix this digital identity crisis?
Well, what's really innovative here is that OmniTalker basically throws out that whole two-stage recipe.
Okay.
It's a unified framework. Remember your chef analogy.
Yeah, one cooking multiple things.
Imagine a super chef who can perfectly cook your steak and your gourmet fries at the exact same time, so they arrive on your plate in perfect harmony. OmniTalker aims to do that for speech and video, generate them simultaneously in one go.
Ah, so it's a digital Swiss Army knife for talking heads. Fewer moving parts, less chance of a digital kitchen fire. Exactly. And the paper emphasizes that OmniTalker does this in real time. So almost instantly.
Real time, okay.
And in zero-shot scenarios. Now, the zero-shot thing is seriously clever.
Zero shot. What does that mean in plain English?
Think of it like this. The system can learn to mimic a new voice and a new face without ever having been specifically trained on that particular person before.
Wait, what? Really? That sounds like magic.
Yeah.
So it can just learn on the fly.
Pretty much. It's like showing a really good mimic a new accent for maybe 5 seconds and bang, they've got it down perfectly.
Wow.
No need for hours and hours of practice or specific training data for that person.
Okay, that's seriously impressive.
Mhm.
So how does this unified framework, this super chef, actually pull off this real-time, zero-shot sorcery? Give us the behind-the-scenes tour, but keep the technical talk gentle, yeah.
My brain still runs on dial-up sometimes.
Uh-huh. Okay. At its heart, OmniTalker uses a special kind of AI network. Imagine it has like two highly skilled departments working together seamlessly.
One's focused on the audio, the voice, and the other's focused on the video, the face.
Like a perfectly synchronized dance troupe.
Exactly. The paper mentions a dual-branch diffusion transformer architecture.
Whoa. Okay, jargon alert.
Yeah, sounds like something out of a sci-fi movie, I know. But just think of it as two super-powered processors. They can handle incredibly complex information at the same time, working in parallel.
Got it. Two processors working together.
So the audio branch, one of those processors, is responsible for creating the speech sounds. Technically, it cooks up something called Mel spectrograms from the text.
Mel spectrograms. Okay.
Think of these as like secret audio blueprints of the words, kind of like a musical score, but for the sound itself.
So it's turning the written words into a visual map of how they should sound. Okay, makes sense.
Meanwhile, the visual branch, the other processor, is busy figuring out how the head should move and what facial expressions to make. It predicts things like head poses, is the head tilted, turned, and facial dynamics, how the mouth opens and closes, how the eyebrows move, all those little subtle cues.
Okay, so one department's making the voice score, the other is choreographing the face. But how do they make sure they're doing the same dance at the same time? How do they stay in sync?
That's where the crucial audio-visual fusion module steps in.
Fusion module, okay.
Think of it as the director and choreographer rolled into one. It takes information from both the audio and video departments, the two branches, and makes sure they are perfectly in sync, both in terms of timing and the overall style. This is what prevents that dreadful, badly dubbed movie effect we talked about.
So it's the ultimate backstage manager making sure everyone hits their mark at the right time.
Precisely. And then we have the in-context reference learning module. This is where that zero-shot magic really happens. Remember our mimic analogy?
Yeah, they just need a quick listen or look to nail the accent or mannerisms.
OmniTalker does something really similar. You feed it a short reference video of someone speaking, maybe just a few seconds.
Okay.
And it can instantly pick up their speaking style, the rhythm, the emphasis, the tone, and their facial style, their typical expressions, how they move their head.
Just like that. From a short clip.
Just like that. It can then apply that exact style to the new text you want it to say. And the key is, it doesn't need any specific training data for that person beforehand. No extra rehearsals needed.
That's wild. So you just show it a tiny clip of how you want your AI avatar to act and sound, and bam, it just nails it.
Essentially, yeah. It learns the context from that short reference.
Okay, mind blown. Let's peek under the hood just a tiny bit more. Keep it simple, though, like making toast.
Making toast, got it. Okay, imagine you want OmniTalker to make someone say, "Greetings, Earthlings."
Classic.
And you give it a short video of, say, your favorite news anchor reading something else, just as a style guide.
Okay, text in. Greetings, Earthlings. Style video in. News anchor talking. Got it.
So first, the audio from that news anchor style reference video gets turned into those Mel spectrograms, our secret sound blueprints.
Right, the sound map.
Then the text, "Greetings, Earthlings," gets converted into a sequence of characters, or maybe sound units. These audio blueprints and text sequences are then combined and padded.
Padded. Like adding stuffing.
Sort of. Think of it like having two puzzle pieces of slightly different shapes. You add a little extra blank cardboard to the smaller one so they fit together perfectly for the next step. It just makes processing easier.
Okay. Making sure all the digital ducks are in a row.
Precisely. At the same time, that reference video is dissected to extract visual codes.
Visual codes.
These are like digital fingerprints of the facial expressions. The paper mentions blend shape coefficients.
Blend shape coefficients. Sounds like makeup.
Haha. You can actually imagine them as tiny digital levers that control every single muscle in a digital face. It allows for incredibly precise and nuanced expressions. Like digital clay, maybe?
Okay, digital clay levers. Got it.
It also figures out the head's pose. Is it looking up, down, sideways? and even tracks eye movements.
Wow. So it's meticulously studying every tiny detail of the reference video's performance, really breaking it down.
Yes, absolutely.
Yeah.
Now, the paper talks about something called the diffusion transformer, DIT architecture. This is the core engine doing the generation.
DAT. Okay.
Imagine a super fancy etch-a-sketch.
Okay, I remember those.
It starts with just a blank screen of random noise, like digital static, and then, guided by your text, greetings, Earthlings,
Hmm.
and your style reference, the news ankle clip, it gradually shakes away the noise, little by little, until the clear audio and video of your talking head saying, "Greetings, Earthlings," in the anchor style emerges.
From digital dust bunnies to a perfectly formed talking head.
Mm.
I like that analogy. It's less intimidating.
Glad it helps. And the way they teach this digital etch-a-sketch to work is through something called flow matching.
Low matching.
Think of it like teaching a puppy. Instead of giving it a whole bunch of confusing, complicated instructions, you use really clear and simple commands.
Right.
Flow matching is apparently a much more direct and efficient way to train the AI to generate those talking head videos. Get it to the right result faster.
Simple commands for a talking head puppy. The future is certainly something. Okay.
And finally, just one more bit, they use a technique called classifier-free guidance, or CFG.
CFG.
This is like having a little internal editor. It constantly tweaks and refines the output as it's being generated, making sure it stays true to the desired style from the reference and boosting the overall quality, like more anchor-like, sharper consonants.
Okay, so it's got its own built-in quality control checking its homework.
You could say that, yeah.
Okay, so we've gone from a clunky two-step process, the cascaded pipeline,
Right.
to this streamlined all-in-one system, OmniTalker. It learns by example from just a tiny clip, and it even has its own built-in editor. So for us folks who don't speak fluent computer, why should we care about all this technical wizardry? What are the real-world aha moments here? What's the payoff?
Well, the implications are huge, really. First off, OmniTalker promises a significant jump in the quality of AI-generated talking heads.
Quality meaning.
Meaning more realistic and believable avatars, both in how they sound and how they look, the movement, the expressions, the voice tone.
Hopefully banishing us from the uncanny valley forever, please.
Haha, well, it's a big step in that direction. And because it's that unified system with the smart audio-visual fusion module.
The director.
Right, the director. The lip sync should be pretty much perfect, no more of that distracting mismatch.
Thank goodness.
Plus, that zero-shot style replication we talked about, that's a game changer.
The learning on the fly thing.
Yeah, the ability to instantly mimic someone's unique way of speaking and expressing themselves from just a short clip, that's incredibly powerful and, frankly, efficient.
Okay.
And let's not forget the real-time aspect. Actually having a fluid, natural video conversation with an AI without any noticeable lag.
That would feel so much less like talking to a machine and more like,
Yeah.
well, talking to someone. Okay.
Okay.
So how could this actually make our work days smoother or maybe our downtime more enjoyable? Give us some practical examples. Where can we see this pop up?
Okay, think about virtual assistants. Customer service bots, maybe?
Right.
Instead of just reading text in a flat, monotone voice, they could appear on screen. They could speak with natural intonation, show appropriate emotions, making interactions feel much more human, whether it's for help desk stuff or even, virtual companionship down the line.
That would definitely make those interactions feel less like pulling teeth sometimes.
Yeah. And online learning could become far more engaging. Imagine complex subjects being explained by a digital tutor who speaks and gestures naturally, uses emphasis correctly. It could make the information much easier to digest and remember.
Oh, definitely. I know I'd pay more attention to a video lecture if the presenter didn't look like they were, reading from a script written by a robot.
Absolutely. And consider accessibility. This technology could transform written text into natural-sounding speech, plus expressive facial cues. Think about individuals with reading or maybe hearing impairments. It makes information far more accessible and engaging for them.
That's a really powerful application.
Yeah. And for content creators, it opens up possibilities for quickly generating talking head videos, for presentations, social media, maybe even personalized messages, without needing to set up cameras, lights, recording equipment every single time.
Right. Less friction to create stuff.
Exactly. And looking a bit further ahead, imagine combining this with real-time translation. Having avatars that can speak different languages, not just translating the words, but doing it with the correct accent and cultural mannerisms, learned from a reference.
Whoa! Okay, that's a big one. Breaking down language barriers, visually and audibly. That in-context style replication really seems like the secret sauce here, doesn't it? Just one example, and it can capture all those nuances.
It seems remarkably adaptable based on what the paper shows. Now, to prove this isn't just, wishful thinking,
Right, show us the proof.
the researchers put OmniTalker through some really rigorous testing. They compared it head-to-head with all the existing state-of-the-art methods out there.
And the results? In plain English, please, no graphs that look like spaghetti.
Okay. In simple terms, OmniTalker outperformed everything else, consistently.
Okay.
The generated audio and video just looked and sounded more realistic. The synchronization between the voice and the lip movements was significantly better. Definitely no more Kung Fu movie effect. And crucially, it was much, much better at capturing those unique speaking and facial styles from the short reference videos. Remember the mimic analogy? It was a better mimic.
So it wasn't just a tiny improvement, it was a noticeable leap forward across the board.
That's what the results suggest. The paper does include specific metrics, things like word error rate, or whir for audio quality, lower is better there.
Okay.
And measures like PSNR, SSIM, FD, and FVD for video quality. Generally, you want higher PSNR SIM and lower FVD for better visuals.
Right, alphabet soup of metrics.
Exactly. But the main takeaway is this. Across all these different ways of measuring, OmniTalker consistently came out on top.
Okay.
And importantly, they saw big improvements in things called EFAD and PFD.
E and PFED.
Yeah, those specifically measure how accurately facial expressions, EFAD, and head movements or poses, PFID, are replicated. OmniTalker really aced these, meaning it's much better at capturing those subtle, very human cues that make a talking head feel alive.
Gotcha. So it nails the performance details.
Exactly. And it does all this at that real-time speed we mentioned, 25 frames per second, which is crucial if you want smooth, lag-free interaction in, say, a video call.
So it's not just smarter, it's faster too. That's always a winning combination, isn't it?
Indeed. So to bring it all together, what's the big picture here? What's the main thing to take away?
Okay, so summing up, OmniTalker isn't just a minor tweak. It feels like a whole new way of thinking about making talking heads from text.
A unified approach.
Right, by integrating everything into one system, the unified framework, and having that clever ability to learn from short examples, the zero shot, in-context learning. It overcomes a lot of the clunkiness and limitations we talked about with the old methods. It's faster, it looks and sounds more real, and it can capture the style, the nuances of human expression in a way that previous tech just couldn't seem to manage.
Well put.
And thinking about that prompt we had, for someone who doesn't have a tech background, the most valuable aspect seems to be exactly that. Its ability to learn a person's style from just a tiny snippet of video.
Yeah, that's incredibly powerful for practical use.
Imagine being able to create personalized training videos, maybe for work, with an avatar that speaks and looks just like you, or maybe like a trusted expert, without needing a professional studio or spending hours recording.
Right, simplifies things massively.
Or think about those customer service bots again.
Right.
If they can actually build rapport because they convey warmth and empathy through natural-sounding speech and realistic facial expressions, that changes the whole interaction.
Exactly. And this kind of leap forward has the potential to fundamentally change how we interact with AI in so many areas of our lives, making those interactions feel less artificial, less transactional, and much more like genuine communication.
It really does make you think, doesn't it? As AI becomes more visually and audibly expressive like this, how will that reshape our relationship with technology? And maybe even beyond that, how might it influence the way we connect and communicate with each other in a world where digital avatars can be potentially virtually indistinguishable from real people?
That's a deep question.
What new possibilities will this unlock? And what new challenges or maybe ethical considerations might pop up as a result? It's definitely food for thought.
Absolutely. And we encourage you, our listener, to maybe mull that over. How might you envision this kind of technology being used in your own life or work? What problems could it solve for you? What new creative avenues might it open up? The evolution of how we interact with AI is really just getting started, it feels like. And OmniTalker appears to be a pretty significant step towards a future where those interactions feel far more natural, engaging, and, well, human.